Hello friends, this is my Stirling engine that I have been making recently. You asked me to tell you about him in more details. Let's see how it works. Yes, it's work. And this is my homemade Stirling engine. In this place it's ice. It's work. It was quite a difficult job, so I wanted to make a single cylinder engine out of beverage cans. So the engine consists of a cylinder in which the displacer is located and a regenerator which needs to be calculated experimentally so that a finger trip can be used in your project. Unfortunately, I had to print a regenerator on a 3D printer, so I couldn't find the right elements. So we start with the displacer. It needs to be made of cardboard. It should not fit very tightly into the tank, and the height of the cylinder should be above 4 cm. It all depends on the size of the cylinder or of the tank that you will use. At the same time, there should not be large gaps as here. The displacer must be lowered by gravity. You need to use 2 buttons to make a tight cylinder, like me. In the center you will need to make a hole so that a wire or fishing line goes in there, and of course the cylinder needs to be cut. To the hole that you make, you must tightly glue a piece of plastic card to avoid large losses of the working fluid, since your engine works without compression. Unfortunately, I can't show it now, but I can say that you also need to make a hole in the plastic card which has the power of a hot needle. You also need to put some kind of rubber tube to avoid getting cold water inside the cylinder, which are displacer. Also, at the top point you will need to make a hole to connect it to the regenerator using a tube. The most difficult part is creating a regenerator. It is better to make it on a 3D printer based on the size of your engine. There is no single instruction here, you have to do it experimentally and independently. In both cases you need to know the stroke length of the displacer and regenerator. In my case, the length of the displacement free wheel is about 6 cm and the regenerator is about 2 cm. Based on this, you should bend the shoulders of the crankshaft, in which the length of their shoulders is 2 times less than the length of the displacer and the regenerator. Accordingly, the length of the displacer arm is about 3 cm and for the regenerator about centimeter. I repeat, the dimensions may not be the same as mine. It will depend on your device. It is important to expel the knees necessary with an offset of 90 degrees. The crankshaft is easiest to make from 19 needles made of aluminium. Don't forget to leave a place for a candle. You can make a metal stand as you want and as you like. Now it remains to reduce the friction forces. For this purpose I used various tools that were at hand. And naturally a flywheel will be required to create the right moments to start the engine and the functioning. The dimension of the flywheel need to be selected experimentally. It remains to admire his work once again and say goodbye to you before the next projects. Bye bye everyone. Sincerely, Yuri Kovalenek.